We've really spent, it feels like decades at this point, building around this idea of I'm going to have this large store of energy that I can always kind of rely on to give me to do the interesting things I want. This has shaped all the ways that we've done computing research, all the ways we've designed devices. Once we take out that reliable source of energy, we have to think about computing in a very different way.
With batteryless IoT devices, we have a completely new notion of energy. With battery-powered devices, we have continuous energy, but it's limited. You have to replace batteries after a few energy cycles. With batteryless devices, you have unlimited energy, but it's highly variable and unpredictable.
So now we take a solar panel or harvest something from ambient RF or motion or soil or any of these other mediums to replace the need for that battery. But if you think of the actual amount of energy we have now, a battery is almost like an elephant. Whereas the amount of energy we're going to get from these energy harvesters like solar panels is like a trickle of ants, like a line of ants running down, right? So maybe in the end, might be the same mass, but there's a huge difference in how we approach this.
This variability causes frequent power failures and produces bugs that are not there in continuous execution. For example, timeliness violation, memory inconsistencies, and safety and liveness problems. These problems can only be resolved by a system support that is capable of protecting the application from these bugs, and existing IoT software support is not capable of doing that because they are designed with the notion of continuous energy supply.
And so those ideas, those challenges, those concepts are what make a new class of computing come out, and also let a research community like ours start to explore and potentially make impact, right, on these hard problems that eventually trickle up, right, into new applications that we can have. An example is thinking, maybe creatively about this is how would I enable smart devices that I wear that monitor my physical health, right? So this could be on, a wrist, right? We're very familiar with Fitbits and Apple Watches. So as I swing my arm back and forth, maybe I can harvest that mechanical energy to then use to do different types of sensing.
I believe energy minimal architectures are really necessary to bridge the gap between the amount of energy that can be harvested and the amount of energy that is required to do the computations. At the same time, with new applications, we'll also need security for these devices. We have to protect these devices since we are not maintaining or supporting them for a long period of time. Lack of experimental infrastructure and formal methods to ensure correct execution of applications in the wild before getting the applications to be deployed is also very important, and to avoid any issues that may appear post-deployment. In between all of this, we also have to think about the users. How are they going to interact with these devices? How are they going to design applications on top of them? So we need to think about programming languages, compilers, and all those tools that are required for these users to design their application. And finally, we need more real-world applications. We need to be able to deploy this system support in the wild to gauge their performance and to know how far we are from making Internet of Batteryless things a reality.
This is kind of already happening, right? So smart thermostats, voice assistants, things in manufacturing lines, wildlife and environmental sensing, wearable devices. And I think that is really that vision of what the world looks like if we have this batteryless, ubiquitous computing of lower ecological impact, more accessible and useful for a much broader audience, and also enabling new applications that maybe we never thought of because we were constrained by the idea of, I have to take a battery and I have to plug this device back into the wall every 6 to 8 hours. What am I going to do with that? How can I think outside that box?